Hello, everyone. In this session, I'm going to talk a bit about some cloud native and GitOps security challenges and give some tools and solutions that Checkmarx has been working on that can help alleviate some of those pains. So my name's Ken McDonald. I'm the chief architect at Checkmarx. For those who aren't aware of Checkmarx, we offer a suite of application security testing solutions for SAST and SCA, interactive testing, and as well as a developer training platform. I'm currently working across our product teams building our next generation application security testing solution. I've worked with many customers trying to understand their challenges and assisting with automation capabilities and helping them solve many security program DevSecOps practices challenges that they face. So if anyone's the same age as me or older, they'll remember a day where the waterfall methodology kind of ruled. Projects moved very slow. You'd plan for 6 months, you'd develop for 3, and then you'd implement for another 6. You'd order physical hardware, take 2 to 3 months to procure, and then another couple months to rack and stack. You'd need a lot of lead time. I've hit challenges where I needed a server and we ran out of data center space. It was extremely frustrating. It was expensive. Everything from backup takes to network switches. So we started moving into the hypervisor world, with VMs. That was exciting, but then we would still run out of the space. We had virtual NICs. This was, we kept growing into this space, and then, eventually containers started taking over, and the cloud native space really kind of sparked. In this old methodology, security, don't worry, you have plenty of time. You'll review the architecture, possibly look at code, and by the time it was deployed, everything was out of sync. So we started working towards Agile and DevOps and all the other kind of patterns and best practices. So we wanted to focus on incremental and short delivery cycle, and we wanted to have more team collaboration, continual planning. And this sounds great. Everyone seems to think they're agile, but in practice, a lot of it becomes chaos, and it ends up being a disregard for process, a mini waterfall, an attempt to rush things out the door, and a lot of chaos at time. And security becomes an afterthought, if not disregarded completely. And as we move into the DevOps
Hi, Ken,
area.
just sorry for the interference. We cannot see your screen if you try to share it.
Can you see it now?
Yes, we can.
Awesome.
Great.
That is not, okay, sorry. I didn't show anything good yet, so that's okay. So as we moved into the DevOps era, there's a lot of talk around DevOps being a team, and it becomes part of a culture and not a team, but with a focus on automation, collaboration, and a core focus on deployments. So within this regard, we don't have time to wait for security teams to come and evaluate what has been done. And so it must be automated, but there still needs to be some manual checkpoints. And if there aren't any manual checkpoints, even from a code review perspective, then we're at risk in these areas. From the DevOps era, we also have stemmed into infrastructure as code, which is extremely powerful and popular now. Everything can be code, application configuration, the OS level, networking, essentially everything managed and provisioned through software files or definition files. This is great, except it becomes extremely dangerous. Changes have so much impact that you could be exposing yourself to attack with a simple misguided and misconfiguration of any of these files. So, and with infrastructure as code, we've entered a new world of DevOps where DevOps has been taken to the next level for GitOps. And it's essentially implementing a DevOps practice with developer methods of managing code and tying it into the infrastructure automation. In theory, it's great. You can go to your code, you see exactly what's in production, you always know what's running, and there's always ways to continually enhance what automation you have within your pipelines, testing, auditability, traceability, and so forth. With all of these cloud native technologies, GitOps, DevOps, and all the other fun, potentially buzzwords depending on how you look at this, we have many security attack vectors that come into play. The number one concern that usually comes to my mind is data and data governance. It's really easy to spin up a new service, have data traveling to a new service, potentially in a cloud managed service or another third-party provider. So the data visibility and the monitoring and governance around the data loss prevention can become a challenge. The data usage, so a lot of activity around privacy controls. I can't go to a site without saying, yeah, sure, I accept your cookies. There's also data residency. If you potentially move your service to the wrong region in the world, it could cause some regulatory challenges. And the next line is data encryption. Is all the data being protected? Is it at the disk level? Is it at the data level? More often than not, auditors accept data level encryption, but yet an exposure through your service can get access to the data in a very easy manner. The next item is access control. DevOps teams need access to the services they manage. So from all layers, whether it's within the infrastructure that's being deployed, the service being deployed in the runtime environments, or the application itself. There's also privileged account management. You have to put a lot of trust in your employees to do the right thing, review the right code, and ensure everything going into the production environment is safe and sound. Another challenge that has come up is around networking and egress and ingress management. What traffic can go talk out to the internet from a pod, from a service, from any part of your network? Is it being managed properly? Because advanced persistent threats could find a little home and just collect and send information all day if we're not careful. The next is provisioning and the deployment and provisioning and governance. If you have a small team, simply just changing code, making changes to production, continually updating and reflecting the current state. If there's not a clean process around driving this, again, we can have a lot of misconfigurations. The cloud provider threats. We trust the Amazons, Azures, and Googles of the world to keep us protected. We lose sight of the fact that they have people, technology, processes as well. And one day, if a threat it was to take them out, it would also cause your environment some challenges as well. And so next, we have to rely on some threat monitoring and response. A lot of times you're missing this. There's a gap. You're not getting the right logs, the right information to the right people to react and remediate any potential threats. API security is a number one focus in Checkmarx right now. We're spending a lot of time in this area. And it's clear that most development's done as an API first methodology, microservices talking between each other. Everything is driven by APIs, how you're securing them, where you're securing them, authentication, TLS, anything under that. So I have 3 items here, and I want to talk deeper about them because this is where we can really come in and help and And it's definitely a very powerful set of tools that we're going to talk through. So dependency management and source composition analysis. It's clear that at any layer, we could have a challenge with our dependencies. The app, runtime, any artifacts essentially could go through some issues. Misconfiguration is the #1 concern I see within the cloud native space and GitOps especially. It simply takes someone reviewing a piece of code to get to production and leave you exposed. And my personal opinion is I feel we lack a lot of the skilled engineers. Right now, DevOps has become an all-in-one IT shop role, and there's thousands of tools, maybe well, probably 1,000 tools, let's say, common tools, and everyone knows enough about each tool to be dangerous and not necessarily an entirely expertise skill set. This type of power and control from these tools can lead to a lot of concerns from a security perspective. And the last component of cloud native, cost management. Too many people have access, spinning up resources gets expensive, not necessarily a security concern, but it could take a business down. So with GitOps, again, it sounds really great. You manage everything as code. Some key challenges I'd like to break down is the auditing of Git history is a challenge. You can do history rewrites. You can impersonate users. From a visibility perspective, maybe not everyone sees code, not everyone understands code. So while you have a snapshot of your environment, you might not know everything going on. There's secrets management challenges. Kubernetes secrets, if you're just using Kubernetes secrets, they're simply base64 encoded, not so secret. You have to leverage a vault properly to manage these credentials. Same with deployment secrets. And from your pipeline and deployment perspective, access control. Who has access to your pipeline tools? Are there any input validations? Changes are very impactful, so must be taken carefully. And of course, artifact management and supply chain integrity. This is all the buzz lately with some attacks that have come through. So now that I've said misconfiguration is a huge challenge, I'd like to just talk about our open source project at Checkmarx called Kicks, and just try to get everyone kind of excited as much as I am to start helping contribute to this project. Again, open source, keep infrastructure as code secure. We have, it's on GitHub. We're managing the backlog, the issues within the project in GitHub. We have a community for coming to ask and talk about what you can do. And I'd like to start just breaking down what is supported within Kicks. So there's many different flavors of the infrastructure as code. We have CloudFormation, Ansible, Kubernetes, Docker, Terraform, soon gRPC and Protobuf, Helm, and OpenAPI Swagger. The rules for querying against your infrastructure as code is written using Open Policy Agent with the Rego. And again, open source, we welcome any contributions, anything that we can do to help secure these misconfigurations in the community would be very powerful. So I've been asked why Kicks? I'm already using AWS config. Why do I need to use Kicks? And my answer is simply, well, actually, why not use both? One's proactive and one's reactive. Pipeline, you can block things in your pipeline. You can have things highlighted as risk sent to your security alerts within GitHub. But pipeline blocking versus an operational incident that you have to react to is my answer. Another piece is the fact that we inspect all the way down to your Docker image and not just your AWS or Azure services. So your Docker, Kubernetes, Helm deployments. And most importantly, it's extensible. If you have a custom rule that you want specifically for your organization, by all means, have at it, submit a pull request, fork, make your changes. And one thing I'd like to introduce is we've launched a developer community called Source by Checkmarx. I can put all these links in the chat at the end here, but this is just a developer community focused for devs, but focused on application security. And I'm actually going to switch my screen over to show Kix right now. So Kix we have again in GitHub, and I just wanted to share within our Source by Checkmarx. I find it very useful myself personally, getting started with Kix part 1 and 2. And so if you're interested in how to just get started, sign up, join, and start playing around, start using. So I wanted to quickly walk through Kix and an example. And under the projects, you can see we manage 2 separate pieces to Kix. And one is the queries. If you have a feature that you'd like to raise or like to contribute to, come and check out queries. It's related to the rules that kind of identify the problems. The engine is specifically around the logic for processing the queries. And so if you want to raise an issue, just come pick which type of category you'd like, a query, a new feature, a bug, and we'll try to get it into the backlog. So my example here is a GitHub action. So Kix is simply run as a CLI tool, and it's extremely easy to run. We have a GitHub action, a Docker image. We'll keep extending this. There's a few different ways to run this. And so I wanted to just quickly show a simple, I have a push and a pull pipeline. So whenever I publish a push event to my main branch, I'm going to run our Kix action. And I'm simply saying I'd like my output to be serif, which is the format that GitHub supports for publishing the alerts to your security space. So when this code runs, it will publish the results. It'll also make an artifact from the serif report. And I can then go here, and my code is pretty sloppy. So I have 78 alerts everywhere from configuration of S3, Amazon specific services, down to some Helm related configurations. I'll just pick one at random here. You can see the lines, the details, some advice. And so it's key to tune your queries so that you can ensure that nothing gets to your production environment without at least passing some basic checks that you hold near to your heart for securing your infrastructure. So again, Kix.io is the project, and feel free to jump on source.checkmarx.com, sign up and join the community. And I will switch back here. So the next piece, as it relates to cloud native software dependencies, this is not a new problem. This is a problem from the past that I believe has been amplified as we continue to grow into cloud native space. Essentially, most of our application is made up of software dependencies. They're potentially riddled with legal risk and various attack vectors. You know, you could be using a package that is completely outdated, vulnerable. There might be some abandoned project that no one's maintaining anymore. Supply chain integrity, whether a change of ownership or an account is hijacked. There's some dependency confusion and substitution. There's several attack vectors, and you can read up further on these if you wish. It's hard as a developer to keep things up to date. The challenge between features, versus tech debt versus bugs in production. A lot of times keeping a dependency up to date is left last, and it's a challenge everywhere I've looked. So enter in source composition analysis, and obviously this is a hot topic in the community. So Checkmarx, we have the CX SCA platform. From here, we like to highlight risks associated with dependencies, transient dependencies, vulnerabilities with your direct dependencies, license implications. Everyone sees when someone gets sued because they're using the wrong type of license or component, or they're packaging it in the wrong way. And a capability I'm excited about is the notion of an exploitable path that we have in the Checkmarx SCA product. Just because a package is vulnerable doesn't mean we're using it in a way that exposes you. So if a developer is really busy, if you're not exposed, move on. I really do feel like you should take a risk-based approach with everything that you do. There's a lot of focus on remediation advice. There's a core focus in the SCA area, and I actually believe that this is a huge piece to the security puzzle going forward, and it'll continue to grow. We will continue to evolve. We have a set of languages and support here, and we'll continue to adapt. And another core focus for Checkmarx is simply becoming part of the developer experience. Get the issues to the developers, into their tool sets, make things as easy for them as possible, and make things crystal clear as to why or why not that you should address them. So I'm going to bring up our SCA product now. And in preparation, I already scanned a project. This could be done through your GitHub Actions, or we have a GitHub app so we can be breaking merges and builds, and we have GitLab integration, but I'm going to be boring and just go to the UI. And so from the UI, I can already see that I have a terrible app here again. I have 9 packages that have legal risks, and I'm violating a couple of my policies I've defined. And so I'm just going to jump into our results for this project in particular. And so I can see what licenses. Obviously, we've highlighted that GPL is unacceptable in our environment. So I've highlighted what is a legal risk. What's most important is the relation, whether it's a direct or transitive, if it's used or not, is where this is a huge win in my opinion. So I'm gonna just highlight one here. So we have our MySQL connector, and we're using it directly. It's a GPL license, which is a concern. Doesn't mean you can't use it, just means it could be a legal concern. You should probably make sure everyone's aware of it. And the most important part is, yes, we are exposed. We are using it right here at this line. The usage is an important step here. So this is where our tools kind of work together. Our SAST and our SCA product kind of correlate together and help identify these challenges. Now, a potentially more complicated use case, I'm going to find one here that's a transitive, and it says we're using it. I'm going to jump in here, and our legal risk is low, but the vulnerability is actually exposed. And it's not directly included from your package manifest, but it is as one of the dependencies of the dependency. But I feel like this is huge. If you're exposed, fix it. If you're not, you have the option to move on. I always highly recommend you build in once a quarter, have a sprint where you make sure you're updating all of your dependencies, regardless of vulnerabilities. There's always bug fixes too. And the last item that I'd like to highlight is simply, again, we try to tie into the developer tool set. So we have scans submitted, providing all the details you could ever want in your pull request while you're doing your code review. make sure that your code is clean. I always use clean code because, for obvious reasons. And then when you get SAST and SCA together, we have the ability to do a deep dive into a particular finding, and this can be filtered down. But the whole point is become part of the developer ecosystem. GitOps is making everything driven to the developer workflows. We need to keep pushing our tool sets for securing the environment to the developer ecosystem. Catch it before it's pushed to production. And I hope I've shown some options here that everyone could use to secure things. And with that said, this is my presentation. If there's any questions, feel free to ask them.